right, so first thing you want to do is you take the function and you would find your x value for your vertex is negative b over 2a. And then you can just plug in the the x value into here and you'll get your y value, negative b over 2a. So you plug that in. Now, the second thing, to find your zeros, set your function equal to 0, solve for x. Two ways you can go about doing this. You can factor it, or you can use the quadratic formula. So you can use x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. That will always give you the values that you need. If it ends up being where this ends up being negative and you can't actually use this, then we know that if b squared minus 4ac is less than 0, then you know you have a graph that's either going to open up and not hit the x-axis, or it's going to open down and not hit the x-axis. If b squared minus 4ac is equal to 0, that means that the vertex is on the x-axis, and if you have b squared minus 4ac is greater than 0, that means you're going to get two zeros. So if b squared minus 4ac, they call this the discriminant. It has a fancy name. Sounds like an old action movie from the 80s. If it's less than 0, if it's negative, you're going to get no zeros. If it's equal to 0, you're going to get 1 0. It's what we call also a double root. And if it's greater than 0, you'll get two zeros, and you'll be able to find them there. What was that? If you can factor it, because then you can find exact values a lot easier and a lot faster. So step 1, find your vertex, find out where that guy is at. Step 2, find your zeros. So this is going to be for zeros. Just set the function equal to 0. Solve for x. And like I said, factor, use the quadratic formula. Either way. Like I said before, you're going to do this one by hand. Now, since I'm jumping around, step 3 here, your y-intercept is equal to c. So, if you have a function that does this point right here is your c value.
Is that 0?
That's a c.
No.
It's not a 0, it's a y-intercept. It's the zeros are x-intercepts. This is your y-intercept. There's only going to be one of those. There'll never be more than one. And after that, make a table of values. I'll show you how to do this. Make a table of values and then surround. I think that's right. Sorry there. The vertex on by equal intervals on both sides. So if you're going to the right by one value, go to the left by one value. Because the graph itself is symmetric. So whatever happens on one side, because there's a line of symmetry that is going to go right through the graph. Whatever happens on one side is going to happen on the other side. So these are your big steps on how to graph a quadratic function by hand. So now let's take a look at an example. All right. Now, I would say that the first thing you want to do is find your vertex. So I need my A value. What's my A value here? 1. So I also need 2 times A, which is 2 times 1, which is equal to 2. What's my B value? 7. And what's the opposite of B? -7. All right, so what this tells me is my vertex is going to be at, the x value is going to be at -b over 2a. What's the negative b? -7 over 2a, which is 2, which is -3.5. So that's your first step. That's going to give me my x values. So I know the vertex is going to be at -3.5, comma, something else. Now, I'm going to take f of, and I'm going to use the fraction instead, because believe it or not, the fraction's easier to use than 3.5. So I'm going to take -7/2 and square it, plus 7 times -7/2, plus 12. Well, plus 7, because that was the original. And then -7/2 is what we had there. All right, so what do we have here? What's -7 times -7? 49. What's 2 times 2? 4. Then I'll get minus 49 over 2. Well, I'm just simplifying. I'm just simplifying that. All right, so if I made this, let me kind of zoom in a little bit here. If I made this over 4, I'd have to multiply that by 2, multiply that by 2. So I'd get 49 over 4 minus 98 over 4. And now I want to put 12 over 4. So I'm going to multiply. I'm going to take 12 times 4 over 4, which would be 48 over 4. Because now I could just add these numbers up. Now what's 49 minus 98?
49 minus 98 is 40.
it would be negative 49 over 4 plus 48 over 4. Negative 1 over 4. So my vertex is going to be at negative 3.5. Now, what's 1 over 4 if I made a decimal? 0.25. Negative 0.25. So I have a vertex. Yes.
So you need a common denominator for both, for the 49 over 4 minus 49 over 6.
Yes. Oh, you can't add them. You can't subtract them unless you do. And so you might as well just make everything into a common denominator. All right, so the next part is now I have a vertex. Now I want to try to find my zeros. So I got to jump to a new page. So f of x was x squared plus 7x plus 12. I know my vertex is at 3.5, or is at negative 3.5, negative 0.25. Now, second thing, I want to find my zeros. Now, the first thing you always want to check, can we factor? Two numbers that multiply to 12. Then you add those two numbers together and you get 7. Yeah, 3 and 4. Now, so I can take f of x and say this is really equal to x plus 3 times x plus 4. Now to find my zeros, what do I set it equal to? 0. Which means this guy here, x plus 3, is equal to 0. And this guy here, x plus 4, is equal to 0. So if you can factor it, because that's the easiest way to do it.
Do you have to factor?
Not if you're either going to factor it or use the quadratic formula. Now, at this point, what number would I have to add to 3 to get to 0? All right, x is equal to negative 3, and here x is equal to negative 4. Now let me ask you this. Do you see a relationship between the two zeros and the vertex? Okay, they're all negative. Negative 3, negative 4, and negative 3.5. Okay, they're all between negative 3 and negative 4. But is there something special about negative 3.5 and where it lies between negative 3 and negative 4? Right in the middle. We could have actually found the zeros first if you wanted to, and then found the zeros and said negative 3 plus negative 4 divided by 2. And that would be negative 7 over 2, which is the x-coordinate of the vertex. So you can go about doing that. Now, we need more points than what we actually have. And so what I'm going to do is I'm going to make a table of values. I'm going to go x, and then I'm going to go f of x. And what I'm going to do is I'm going to put my vertex right in the middle. Because I know my vertex is at negative 3.5, and I know that's negative 0.25. And then I went negative 4 here, and I went negative 3 here. And what did I get for these values? And it just so happens that in this case, the zeros are really, really close to the vertex. Now, I would go negative 5 and negative 2 just to get more points to make a better graph. And I'd go negative 6 and negative 1. Now, what's between these two values, guys? Both of you are talking too much. If I'm going from the vertex here to here, how much am I going to the right? 0.25 to the right. How much to the left? 0.25. To get from negative 0.25 to 0, I have to go 0.25, and that's a 0.25.
But was it 2.5 or?
That was just to get from, if I was working here. Now, the nice thing about the quadratic function is all you have to do is work one side of the problem. So work the easier numbers. Like I'm going to take negative 2. And I'm actually going to use this. F of x is equal to x plus 3, x plus 4. And so I want f of negative 2. So I get negative 2 plus 3, negative 2 plus 4. What's negative 2 plus 3? 1. And 2, so this is going to be equal to 2. So I got a 2 here. Now, the nice thing is, since this is minus 1.5 and this is plus 1.5, what happens here happens here. So if I got a 2 here, I get a 2 here. Same value. You get the same value. If you want to check it, f of negative 5 is going to be equal to negative 5 plus 3 times negative 5 plus 4, which is negative 2 times negative 1, which is 2. So you're going to get the same answer. And that's why we want to make sure that we're going at the same intervals. Now, since I go and I basically I'm adding 1 here and I'm adding 1 here, and I'm subtracting 1 here and subtracting 1 here, whatever I get here is going to be the same as what I get here. So I'm going to take negative 1, plug it in the equation. So negative 1 plus 3, negative 1 plus 4. What's 3 minus 1? And 4 minus 1 is, what's 2 times 3? 6. So what's this value over here? 6. So now we're going to take all this information that we have, and we're going to graph it. Now, ladies and gentlemen, if you are graphing anything, it has to be in a nice, neat graph. If you have graph paper like this, you're going to graph. I'm just going to take this and I know my vertex is at negative 3.5, negative 0.25. I know my zeros are x equals negative 3, x equals negative 4. And I had a table of values. It went 6 to 0, negative 0.25, 0 to 6. So I can take, and since that's negative 1, negative 2, negative 3, I know I have a 0 here and a 0 here. So those are my zeros. And with the vertex, you're going to do the best you can. With the vertex at negative 3.5 and negative 0.25, negative 3.5, that one's kind of easy to eyeball. But the negative 2.5, you're just, like I said, do the best you can. And then what did I get at negative 2? 2. So I'm going to plot that point. What did I get at negative 1? 6. 1, 2, 3, 4, 5, 6. Now, all right. Now, the reason why I did this is when you're graphing the function, if you draw a vertical line right through the vertex, what's the distance between this point here and the vertical line? 1.5. So I go a half, then I go over 1, and I could just plot that point right there. And then this one is 1, 2.5. So it goes half, 1, 2. That point's right there. And then you do your best to hit all the points. I didn't do a great job over there.
It's good.
But it's a sketch.
Looks same.
Question?
I can still do without the point. Should I show the point? Okay, can you go just to see something?
What?
The other point that you write. Can you see it, please? Yeah. You good?
Alright, let me stop the recording because you guys are good with that now.
Can you fill
in a second. If you guys were talking less, you wouldn't have to.
We weren't talking about like the extension. I need to review it.
I think so. We need the points.
You got an idea? All right.
Can you do it?
As soon as we're done here, I'm going to show you on the calculator what you can do.
I mean, can you do the polynomial example? Like,
Yeah, we're going to get to it. Yes. Ladies, turn around. Nothing good's going on back there. Nothing good's going on back there. All right. Now, as some people are wrapping up the notes on this one, all right, that's uploading. But what I want to show you here is, can I switch the view?
Yeah. Are you still recording?
No. All right, let's make this a little bit bigger. All right, now, if you have the graph, and this is pretty much how we're going to graph any type of polynomial that we have. In this one, we had,
When we go to graph,
yeah, you put in a graph screen. And then we're going to put in x squared plus 7x plus 12, and you hit enter. And what I want to do is I want to zoom in a little bit more here. So
I think
now, our vertex was right down here, wasn't it? And our zeros are right there. So what we can do And this is what you can do for every single graph. So this is not just for a quadratic. This is for every type of polynomial graph or any type of graph that you're dealing with. If we go to analyze graph and we want to find a zero, we go to the zero, and then down here it says lower bound. So there's the zero I'm looking for. And there's a dotted line, and what I want to do is I want to create an interval around that. So I want to tell the calculator where to look. So I need a lower bound, a left bound. And then I want an upper bound, and as soon as it says 0, I'm happy. And I got my 0. I'm going to grab this and move it over here so it's kind of out of the way. And does that make sense that we had our x at -4? Isn't that what we got? Okay, so that's what we ended up with. And I want to find the second 0. So I'm going to go back to menu, analyze graph, and do a 0. And then I want to, since there's my second 0, I want to go to the left of that. And then when it says upper bound, I want to go to the right of it. And I got -3, 0. Are those the